We can make a start. So welcome everyone to the performance and capacity stream. My name is Piara and I'm going to be chairing this session. We're very pleased to have Dan Ruel from 21st Century Software. Um, we will have some time towards the end to ask Dan any questions, or you can also ask any questions as we go along. And to do this, just simply type your question in the chat box. Or if you would prefer to speak, I can unmute you if you just let me know. As with all of our sessions, we would highly appreciate any feedback, and I'm going to leave a link in the chat box so that you can do so towards the end of the presentation. I'm now going to hand it over to Dan to start the presentation.
Good day, everyone. I'm Dan Ruel. I am in Atlanta, Georgia, where it's cloudy here, but warm. And this deck, what we're really going to talk about here is how to, I'm going to make sure I can advance the slides here. What we're going to talk about here is how to really do capacity management. One of the products that I use, I use screen snaps of the product, but it's really, any product that you have in your environment that's similar, you have the same kind of capacity process. And as Piara said, please interrupt with any questions, either audio or type them into the chat. Welcome any kind of questions that you have. So I've been in the business a while, and various industries and experiences. I've been involved with Share, CMG, GSC UK. I'm a bike rider, and in Atlanta, it's easy to ride bikes for most of the year, actually. Today's world, we're going to just really talk about what skilled people are needed. It's really all hands event that I actually, where I got the title was I was talking to a customer and they had a Monday acquisition that they were bringing online on Monday, and they were canceling a meeting, and it said it was all hands monitoring event. So this is out of the spirit of that this title actually came about. So the challenges we have, I think a lot of these are probably things that you've seen in your own experience, is that workloads are becoming less predictable. The variability of the business, and also the environment, this the physical software and hardware, because of CPU and memory that's available. It depends on what work is running. All these workloads are becoming less predictable, and so being able to have like almost near real-time information on the environment is important in order to react quickly before response time degrade and you get service calls to the help desk. That pushes into any kind of decisions that have to be done in a timely fashion. You have to have good automation so you can respond quickly, because you can't be looking at your screen all day, and you have to have good exception reporting. And all this ties into incident, problem, and change. In some environments, there's some homegrown capacity reporting. That is a challenge, because a lot of the reporting that you do, there's an analysis on the back end once you have the report. So homegrown reporting, creating your own reports, makes it kind of interferes with the analysis side of the house, because sometimes you have to write some reports in order to get the answer for root cause analysis that gets fed into incident, problem, and change. And then finally, most customer-facing applications are completely dependent on mainframe processing. This is just true across the world. Many of the top 500 companies in the world are dependent on mainframe processing. And I should also state that a lot of what we're going to talk about is really applicable to any kind of platform. So when we talk about these things from a capacity management process, I've done other platforms too. They have the same kind of problems in terms of what is going on. Everybody can see my screen okay, I'm assuming, right? Please interrupt if you have issues with or have any questions.
Yeah, we can see okay.
Good. So in my environment, in the previous environments that I was, there was the plan events, understanding critical business services reporting. It had to be comprehensive and timely. So if you were doing an acquisition and you doing an application change like on Sunday morning, on Monday, you really had to have information available because your management team would be asking, how is this new application change running? So it had to be timely and comprehensive to be able to understand the environment. And then you had to communicate it to different audiences. And then you might use manual AI methods to actually quantify what was going on in the environment. In everybody's environment, there's unplanned events. The overall goal is to return to service as quickly as possible, document the problem and adjust the plan. And again, you might be using manual or automated methods to see what was going on. I've done a number of postmortems, but I would include postmortems also if we had a data center change where we moved data centers. Some of those postmortems are, planned events too. But most of the postmortems I've done was looking for root cause indicators and then to be able to adjust the forecast because that might be the new normal. And being able to use drill down reporting really helps in fastly delivering postmortems. For I don't know, about 15 or 20 years, I've been thinking about capacity, performance, and costs with this Venn diagram where, this capacity is scalability, performance is service levels and costs, which would include showback or chargeback, or also vendor SCRT type reporting that you might get from your vendor. But all these are constrained to each other in terms of the reporting that you need to deliver any kind of reporting for planned or unplanned. So on the capacity side, you analyze current capacity, and then performance, you want to make sure whatever capacity you have, you'll be able to plan for the future, and you determine service levels. And all these are constrained by how much money you actually could spend on the infrastructure. Some of the obvious things here is the business is enabled by technology. So typically, I worked at, for instance, Delta Airlines. We would get a call in, but it would be a business service that would be identified on the help desk. So any kind of business environment had to, any business service had to be linked to the technology, be a CSS region or a DB2 task that are running. All this had to be linked together in order to respond quickly if a business service was not meeting its service levels. The technology must be scalable to meet peaks. We had different peaks for various places I worked. So you had to have the technology always be planned for peaks and to be able to meet the service performance levels, and cost effectiveness, no matter where you work, was always a universal goal. So this is kind of the way I kind of view things in terms of the day-to-day operations and process. Whatever product you have, is that you have history, which, I've been doing this for let's see, I was a mix administrator back in the 80s. So back here, we had all the history, we would feed it into consumption measures, and then we would put it into a historical database. Ultimately, the capacity planner would take their business forecasts and apply whatever forecast they had to the historical database to be able to plan for the future. What changed in the last several years is that near real-time collection, curation, and presentation of the data became more important. So if you had a change that happened on Sunday morning and then on Monday the transaction started executing, having near real-time or updates throughout the day of the data is really important to be able to understand if you're meeting your service levels. So back when I started in the business, it was usually we cut the data at midnight, and then by 6 or 8 a.m. on Tuesday, we'd be able to actually be able to see some of the reporting and see what applications were meeting their service levels or are missing their service levels. So near real time is really a game changer in terms of understanding what's going on. And all these measurements, the performance measurements, the capacity measurements, the cost measurements, they all feed into being able to understand and that you're meeting your service levels, and you're able to characterize the work that's going on and whether or not it's meeting your forecast that you had. So in terms of foundations on how this is done, the data collection process has to really be automated. This has been going on for a while now, where you have automatic collection process. When I first started, it was all man data sets. Now they're log streams. So I think some folks are still doing log stream, man data sets, but all the SMF processing that's coming on, and also if you're running other products that may not have an SMF record like IMS, all this has to be curated, aggregated, and put into a performance database. And then just selecting the key data is important. There's tens of thousands of metrics that are possible when you're collecting data. But just looking at the data that serves the performance, capacity, and cost of the product is fundamental. In terms of communication, one of the things that I've discovered early, because I had the role of capacity planning, I had a technical role where I would be doing capacity planning, doing forecasts, but I knew that the work that was running on the system was impacted by these folks over here in the business management side that would know that there would be a marketing campaign or other increases that are going on. So understanding from a technical perspective what the technical assets are, and then what the business forecast that matches to that is key to in understanding how to make a more accurate forecast. And so all these two really played a big role. For the most part, these two pieces, and I'm going to talk a little bit later about where the variability is, but these two pieces were somewhat predictable if there was a communication that was happening between these two rows. The other piece of the forecast that sometimes was more variable was application development. This is where most of my variability happened, was in application development. When there was a new change put in, a new application, there's challenges with, obviously, if it's a completely new application, not a change to an existing one, but all this has to be really tested, and we'll talk a little bit about that later. And then the technical role, I would also be interacting with, on the chargeback side or showback side, with IT management. They understood all the salaries in the environment, excuse me, all the salaries in the environment, all the software costs and all the hardware leases and all that. And so the technical role, and these folks here would be a key piece in arriving at good rates, chargeback rates or showback rates for the work that was running in the system. And there's a bunch of different precept concepts that are important, like being able to make it predictable so they could budget, their IT costs. So communication is a key part in working any kind of system management reporting. The forecast accuracy, I talked previous slide on forecast accuracy. So there's, on the forecast accuracy side, there's usually a business request where a business wants to do something, they design it, but at these points here, you really don't have any code or any estimates to understand, what's the impact of how many service units or MIPS that you might consume, or CPU seconds, or disk space, or whatever you're forecasting on. So these two steps here, you would not have any accuracy really. You might be able to guess, but the guess would be simply a guess. They would build it, and then you start testing, and at this point, you start really understand, well, this is it's this big, but it's not until you get into final code, and then finally stress testing. And stress testing means make it look like production peak, where you actually can measure it and be able to input that to your forecast. Any questions on this? The other piece here is whenever a change is defect measures are important. So whenever a change happens in a agile product cycle, actually understanding the incident tickets that come out of the change, and if it's a repeating defect that you see, this should be part of your forecast too. So the ongoing process is it's a continuous process that happens. There's stakeholders that are part of running an effective capacity management process, but monitoring real time and also trending data. There should be analysis. It's not just keeping the data, but there should be analysis where you provide the proper analysis and reporting for the audience levels that are looking at this data in order for them to accomplish what they're trying to accomplish. And then out of this historical data, you can do forecasts and communicate results. So all these pieces should be playing a part of this. I found that in the past, whenever I was in a role doing capacity performance or costs, that many times the application folks would be just interested in service levels and performance. A scalability issue, they, you know, in the application areas, they just felt it was unlimited. And so really focusing in when you have meetings, like hopefully monthly capacity meetings or application meetings, that you talk about each of these different areas with these folks, so they understand they understand when you're writing code, they have enough scalability in the code, and they actually plan for scalability, and they also plan for costs to make sure they're, whatever code they write, it's not just about the service levels and meeting the expectation of the end customer. They have to be able to scale for their peaks too. And communicating this is really important in the process. And then within incident, problem, and change, these folks here, the stakeholders, they have different levels of experience in terms of understanding this piece. So whenever you're talking about root cause or documenting an incident or a problem, to if you identified a scalability issue or a service level issue or a cost issue, you should really talk about those kind of things within the incident ticket that you're doing. So the next time that problem happens, it could be an ongoing conversation, and they could put pressure on the application folks to, you know, understand these three things too. So try to get the stakeholders to work for you too. All right, I put these in order in terms of variability. And so the application area, this usually was the area where I had the most variability in terms of my forecast. So new function was the first one that I would have variability. I do remember on one Monday, we were talking earlier before I got on, I'm thinking about writing another deck called Stormy Monday, but on one Monday, they just put free space in the vSAM files for a CSS application. And that tanked the response time of everything that was on the system on Monday. It took us 2 days to figure out what was going on in that. So new function or enhancements, this is a key piece that happens. Defects are things like if wrong data is read into the system, some of the data, you know, from other distributed systems may not be formatted correctly. I've had that happen, where defects caused applications to fail. And when applications fail, you have to rerun that work, and you take up more capacity as a result. And then there's architectural limitations, which should be communicated when that's happening, and look for ways to optimize architectural limitations. Example of architectural limitation I had in the past was a CSS region being dispatched to an engine that was using about 65% of the engine, and the response time started to degrade as a result. And so either buying a bigger processor, going from like a Z15 to a Z16 is one solution. And the other solution is making those transactions thread safe so they can dispatch to another engine. And obviously you have to have other engines to do that. So that would be an example of architectural limitation. Scheduling, a lot of times, you know, when you have a peak that's causing you pain, you know, scheduling would be, an example would be if you schedule everything to run at 10 a.m. And instead of maybe staggering it, that might be an example of scheduling where you can optimize the environment to smooth out that peak. Software, sometimes new ZOS software, either CSS software or there might be a bug in the software that would cause an issue. Hardware, I think everybody's had hardware failures in the past. And then this side here, remarkably, other than obviously the last couple of years, it's been remarkable in terms of news events. The biggest news event was that I had when I was at Delta Airlines was everybody was looking for refunds on their tickets, so that the places where this was done, that was put a lot of strain on that, and we had a plan for capacity there. New government laws sometimes impacts your forecast. All right. So in order to understand what's going on within your IT assets, it's important to map your technology to the business, and this is no small feat. And they have good business application monitoring to be able to understand what technology maps to what business service. It takes a lot of work, and application areas are constantly really changing those things up and maybe mapping different assets. So it's an ongoing thing. It's not like a one and done thing. So you have to have a process in place to constantly be doing this. And then map those to service levels, and then mature your artificial intelligence, because there's a lot of pieces to the puzzle to figure out, where your forecast should be and how do you support your business. All right, the common methods for measuring. I looked at top 40 reporting. You take advantage of technology like Zips memory, and making sure that, as probably most of you folks might know, watching the whether or not your zips are being fully utilized, or if you have enough zips in order to decrease your costs, is important. Memory plays a part in decreasing your cost, and then aligning your planning with business in terms of the vendor costs and your predictability here is really important. All this, there's a lot of measurements, tens of thousands of measurements that go on. And so self-service reporting is really important to get to, and to have the variability where you can change your reporting. The end user can change the reporting to do their own reporting and enable that. It's really powerful to be able to do that. What I did here in the next, let me take a drink here. I did some examples of different reporting that would be representative of capacity, performance, or cost. So you do top 40 reporting. You're looking at peak detail intervals where they can hurt you. Capacities planned for normal peaks, not abnormal peaks. Normal peaks. They're try to have as many normal peaks as possible and smooth those things out. Looking for the top workloads. So if you want to decrease costs, which this row here is an example how this ties into cost. And then profiling your work so you understand what's going on. Understanding how your workload behaves in the context of the business. And then forecasting. Usually if you're in an environment, most business environments, it's always growing. So looking for forecasts and ensuring that you have enough capacity is a key piece to meeting your service levels. In terms of service levels or performance, you have similar reports. You have top consumers. These top consumers, like in transactions, will be the ones you should focus on and make sure there's the components of those. Any of the top consumer being DB2 or batch. Understanding the different pieces of the response time, which is CPU, IO time, and other delayed time. Understanding those pieces, and then tune the largest pieces of the response time to ensure that your service levels are working. our service levels are within the business objectives, I should say. And then having service level reporting, this is great reporting to actually send back to different audiences to make sure that they understand that, yes, we are meeting the service levels. In the past, I've had some arguments where people felt like the response times were bad, you know, on Monday at 9 o'clock, but being able to have objective reporting that says, no, you were within your service levels that we agreed to, despite the help desk calls, we do see proper response times within your service level. So having this reporting from an objective perspective is really important. It's also important, you know, from a service level perspective to understand all pieces of the service level from a customer perspective, because there's probably network time here that they may not be seeing. But ensuring pieces of your service levels that you're responsible for is important to have objective reporting. And in profiling, this is within the service levels, understanding the different pieces where you might be outside your service levels and understand where you potentially might have a problem. Looking at the LSPR, relative nest intensities, this is what this type of reporting is. And then alerting, if you're doing near real-time SMF collection, this exception console is a game changer to be able to see exceptions like performance index, for instance. The performance index is an indicator whether or not the WLM goals are being met for a particular service class. So having exceptions, and this is a really, if you're doing near real-time reporting, this is very useful for the operations area to be able to have that kind of environment available. Finally, I look at, from a cost perspective, I look at two pieces of the cost perspective. One is the vendor software billing. And typically, well, there's a third option. You might have an enterprise agreement, but you might be running MLC, which is peak 4-hour averages for the month, or you might be running TFP, tailored to fit pricing. And showback or chargeback is always custom. You know, you might have some custom reports to reflect your charges back to the application area. So if they made a change, it's really useful to be able to mount that back to the application folks to say, this business service worth this amount of money we're spending on this, on the infrastructure side. Finding data in context. So there's a multitude of measures that can be on a dashboard. Ensuring your prime shift is focused on peak for forecasting reasons, and then monthly time spans, assuming a good prime shift is as important as details. The monthly time spans are contribute to a long forecast, maybe going out 1 or 2 years, and good visualizations, because there's so much data can help you find root cause and then be able to column sort on response times, you know, the components of response times. I see some chat. Is there any questions?
We've got a question from BMS. Username, they're asking, have you ever found a capacity modeling tool that can merge demand step changes, peak workload view, hardware capacity, and future growth?
I'm not really talking about product here specifically, but I have used product queuing modeling products that you could forecast a workload view. The data itself, the SMF data itself, you know, it's grouped by service class, and you certainly could trend that data, and that's how I would do like a workload view. And then report class, not just service class, but report class can then differentiate into specific like business workload. All this fits into the hardware. You know, you could add up all your service units, and your capacity of your hardware has a certain capacity limit. And so based on that, you can do a trend. Does that answer the question? Does that help?
Hopefully that answers the question, BMS. Yeah, I think it does, yeah. He says thanks.
It takes, one of the things that I've done in the past is that I don't have it in this deck, but what I did was, I talked about the variability of the different forecasts that can happen. I basically, that's an outgrowth of my categorization of my forecast. So like if you did a forecast every quarter, and you probably should do it at least every quarter. So if you did a forecast every quarter and then categorize it, and then you start improving that. So if your forecast was off because of a business forecast being bad, then you start working on making that business forecast better. And so it's a ongoing process where you might have a goal of no more than 10% variability in your forecast. And then, from time to time, you have to categorize it because you got to work in the specific areas where it's in error. And that's why I have that slide in there. All right. All right. So one of the things I like about this type of view, any kind of view like this, where you see the data intraday during a day, you see all these different forecasts. So if you see an increase here, you might see an increase on the workload side. These are workload categories, which roll up into service classes. So I'm seeing this data on an intraday, like at usually, like as an example, 9 a.m. to 11 a.m. is your peak. Maybe at 11 a.m. you start looking at it, and then being able to switch from, if it's Monday, look at the previous Monday, and 2 Mondays ago, 3 Mondays ago, and so forth. So doing comparisons on an interactive here is extremely useful. Trying to change the slide here. The system can add a spike in the middle of the day. Whenever you see a spike, you drill down and see what caused that. You see it looks like on March 1st here, the spike happened. So you might drill down into March 1st and find out what workloads caused that spike. You drill down by report level, reviewing monthly data, being able to, this is really a slide about how the different summarizations play a part in understanding what's going on. So if you're looking at monthly data, all this gets smoothed out, even if you're looking at a particular shift, and then toggling into daily, so you can see what parts of the month was high. That's pretty powerful to be able to do that. And then looking at within the particular days, you see all these spikes here. So all these spikes here, you don't really see them here. So I'm just pointing out that different time spans yields different results in terms of your understanding. And if you had these spikes, and these are up a certain amount of MIPS, does your environment provide enough capacity for that peak? That's the question. These peaks are what's important in terms of doing capacity. And this, it gives you a general guidance that you're meeting it. So you have to understand what your standard deviation is between these things. So drill down by system category. So in this case, I'm drilling down by these categories and seeing, which of these peaks here are driving it. In this case, it's batch that's driving this work. So the next step from here to here is looking at the categories of work that's running in your system. Obviously, within these categories, like batch is certain application batch jobs. Within DB2, the database type work, it's certain DDF work and also DB2 applications that are running. Within online, it's certain, either CICS or it could be IDMS or any other work that's running in that environment. So figuring out which of the workloads cause the spike, and then once you know which workloads are causing the spike, you're one step closer to talking to application areas, typically, at least. This could be, in this case, it's system, so maybe it's an IBM software bug. Perish the thought. And then finally, this is looking at service classes, and this is this service class, and this is all this CSS work that's going on. And it's just, this is a demo system, so I know that it's not as demanding as probably the work you're look at on a typical basis. But looking at these service classes from a normalized CPU perspective is important. And one of the pieces of this is LSPR workloads or relative nest intensity. You get, with different relative nest intensities, your capacity might be different. So understanding the hardware is related to what you're seeing on your report is important. Finding outliers. So there's different outliers in scoring. So having a scorecard to be able to look at different outliers and this type of reporting from a scorecard perspective, this is a useful scorecard to be able to see from a system assurance perspective. Is my basic infrastructure performing as expected? So if you did an upgrade over the weekend on Monday, you might start looking at your key metrics for the infrastructure as a base. And so this provides that. So if you went from a Z14 to a Z16 and you suddenly had more parked engines, that might mean that you may need less engines in that environment, for instance. If you did an upgrade and you still had work running on CPs that you really should be running on zip, it'd be important to maybe add more zips to your environment. So all these different pieces is important. And then looking at history to see, is this a one-time event, or is this been happening, for the last several days? So this is another example, just an overview of looking at everything at once. So then you can zero in on the specifics and then look at the detail. In terms of alerts, there's this, in the world I live in, there's a static alert, which I think most of you folks are probably are familiar with. If, for instance, a coupling facility above 30%, you start being concerned about the CF running too busy, but that would be an example of a coupling facility. Dynamic alerts are really looking at the different intervals during the hour. And then if you had one interval during the hour that was, 100% larger than the other, that would be flagged as a dynamic alert because it exceeded the standard deviation. So it's looking for spiky outliers during the hour. It's important for maybe a transaction response perspective. These dynamic alerts can be really useful. Having console look, this is what I've showed in a previous screen, but having a composite of all the alerts that are going on in this system in one easy fashion where you can drill into these things and look at, for instance, a PI, a performance index that's exceeding its threshold, and then drilling into that to be able to find out what's going on is extremely valuable. So this, in terms of dynamic alerts, this is examples of some dynamic thresholds and some examples where a dynamic threshold is extremely useful. If you're doing data sharing, this would be a great coupling facility alert from a dynamic threshold to flag a CF that's causing issues. So dynamic thresholds, here's some examples of dynamic threshold, LPAR CPU busy that we had an alert here. And maybe, when you see these alerts, looking at the incident tickets to see if there was any incident tickets during these intervals might be a useful thing to do. It all ties back to those other stakeholders that we talked about. Here's another example from a PI perspective. Did the work that was running in this service class here, have any incident tickets when you see a very abnormal dynamic alert happening? This is only 15 minutes or 10 minutes, depends on your interval. Workload characterization, average of hours, looking at automated critical alerts. It's useful for finding changes in applications. So being able to see a system, and this is an example of looking at 2 standard deviations above the median, 2 standard deviations below the median, and this is the median here. To be able to see if somebody made a change here, and maybe it started here where it started here and then suddenly it decreased, was there a problem where there was data not coming in? And the reverse can also be true. In terms of a service class, seeing differences in the service class, there's a lot of variability here, and being able to see standard deviations and changes in this data. Looking at every hour, going back from December into May, and looking at every hour and seeing what changes have happened. These, from a service class perspective, then you'd have to map back to the application areas. And then group, oops, sorry. I should get a better mouse. So from an application perspective, grouping applications, service classes into applications, and then tracking these applications for spikiness and smoothing this out, the peak to average, smoothing this out so it's more predictable. These peaks are not good to have a very peakiness in the application. And then looking at jobs. So jobs is probably a very useful thing. I had to look at SMF, but you have real production batch jobs that are running. But if you had an application batch job that was one of the biggest batch jobs that run in your system, and being able to see the changes from a statistical point of view, you'd be able to track back to what was going on that job and probably match it back to an application change typically. And then forecasting and simulation. So this is a reminder of some of the variables that I saw when I was in the categories I would then classify my forecast variance into that need to be thought of when you're doing a forecast. And so you might wrap some more functionality or analysis into the variables that cost you the most in terms of a wrong forecast. This is natural forecasting units. This has been around since early days that I was involved with the Computer Measurement Group, CMG. And so natural forecasting units are simply, where 50 MIPS or 1,000 service units equal 1,000 customers. Just something where, if you had a marketing forecast that you're going to increase your business by 1,000 customers, what is going to impact your system. So this is how you would tie the business service to the technical asset to be able to predict where you're going to go on your hardware in order to ensure you have enough scalability and meet your service levels. And then business application forecasts using history to predict the future. And so having history, and you have to have it summarized properly in the proper shift. So if you're doing a shift that's 9 a.m. to 5 p.m. and maybe just your morning is your prime shift, you might want to consider maybe breaking that shift up into sub shifts and doing a forecast on that, because this is where you have to really have the high utilization so you can ensure you have enough capacity. So LPAR metric during if you're going to do workload simulation, the things that are really important are, what are the MIPS available or service units available? What's the degradation factor? If you increase the environment, what's the expected transactions and the actual transactions, and what is the degradation response time? And then the transaction average response time, what would that look like? These are all just common metrics that you might be tracking in your process. And batch workloads, batch works a little bit different. It doesn't have to be interactive. So batch, might run a little longer. This, if you run an MLC and a software cap, this might have a different impact. Typically, in the past, we would elongate our batch to run longer and just push the software cap down enough so interactive meets the capacity. So being able to forecast it from a forecast perspective, this is something to consider. And then this is just a visualization on, response degradation over time and elapse elongation by scenario. You'll have different scenarios potentially. Like if I had 500 customers versus 1,000 customers and so forth, you would run these different scenarios to be able to report to your management team and say, how much do you want to invest? So that cost thing out of the performance capacity cost is important to, communicate how much do you want to decrease your risk by infrastructure investment. So knowing how your business fits together, you got to map technology to business services, communicate current expectation of future service levels, and then mature your artificial intelligence. Some of the, using standard deviation and pieces there on understanding how the work is running, and then do self-service reporting to free up more time for analysis. So that's all I have. Is there any questions?
Nothing in the chat box as of yet, Dan.
All right.
We could just give it a few minutes in case anyone is typing. Just as a reminder, you can type your questions using the chat box.
And please submit your session for your session feedback.
Yep, and I've left a link for that in the chat box as well. So it literally just takes 60 seconds to complete. We'll give it 30 seconds.
Well, I hope that hopefully we'll all see each other at GSC UK in November, I think it is.
Yes, so we're in November in person.
Yes, I'm looking forward to that.
Okay, well, no more questions coming in at the moment. Thank you so much for your time and for the presentation, Dan.
Yep.
If anyone does have any questions that they think of later, I presume they can also get in contact with you by email as well.
That'd be great.
Will be on the session slides that you can download via the agenda website. But we'll give 10 minutes back to everyone that joined. Thank you so much, everyone, for joining, and thank you once again, Dan, for the presentation.
Thank you. See ya.
See ya. Bye-bye.